Hi and welcome to this video in the Understanding Concept series, and in this one we're going to look at the main tools you have when you use the preprocessor in MRDCL. So first of all, what is the preprocessor? Well, it is what it says it is. It's going to make your code and pre-process it so that it will use an expanded version of that code when it actually comes to run. So let's look at a very simple example of this before we go too far, and then we'll look at the detail in a minute. So let's look at the file here and let's just key in some script. So I'm just going to key in some very basic script in here. And I'm just going to put in the most simple loop I can. So this is what a preprocessor code looks like. It always goes in square brackets. Okay, so this is a very, very simple loop. And let's save this now and just compile it. I've defaulted it to compiling, and it's sure enough it's compiled. So what I keyed into this STP file was a loop which is going to go round this code 5 times. But actually what MRDCL is doing is expanding that code, and it's running what you'll find in the listing file. That's the code it's actually running for me. It's as though I actually keyed this code in here rather than the shorthand code. So all that the preprocessor is effectively is a shorthand way of writing something that you could just sit there and copy and paste. Those statements there's only 5 of them. If that was 50 of them, that would be a fairly laborious task, sitting there copying and pasting and changing underscore 1 to 2 to 3 to 4 to 5 and the column number here to 6, 7, 8, 9, 10. So there's a good reason for using the preprocessor. It does really reduce your errors, and it means that you're writing the code in the most efficient way. But that's what it means, the preprocessor. So it's actually doing all this expansion of code before it actually does anything. So if I make a mistake in here, let's say I put an extra square bracket in by mistake, that's invalid code, and the run will crash, and crash very quickly. It won't even get as far as compiling, because what it's going to do, it expands all my code into the long form that we saw just now and then runs it. So an error in the preprocessor means it crashes straight away and doesn't actually get as far as compiling. You see, it's gone into the compilation phase and it failed before it got to the end of it. So we'll look at dealing with errors in a subsequent video, because error detection is something that you need in the preprocessor when you're using it, because it is easy to make mistakes. But let's concentrate now on getting this fixed and looking at the tools that you have available. Well, although the preprocessor is a little bit more complicated to use than perhaps just ordinary script, it doesn't actually have that many commands that you have at your disposal. So you really only need to learn how to use 6 or 7 commands, and you really have learned all the tools that there are. Now, the first thing to say about the preprocessor is that if you ever find yourself copying and pasting code, you probably should do it in the preprocessor, because copying and pasting is a notoriously easy way to make mistakes in your script. So it's really not advisable to do that if you think you're going to do something that's repetitive. All right, so let's get into some code now and start looking at things that we can do. And the most common tool you have is a do loop here, like this. So what this is saying is that I want to do a loop called A, which starts at 1 and ends in 5. So it's going to go through this line of code here 5 times, with A having a value of 1 the first time, A having a value of 2 the second, then 3, then 4, then 5, and then that will be the end of it. That will be the end of the loop. So that's my loop. It's going to go through that 5 times. The name I give that loop, I've given it the name A here. That's a fairly common thing for people to do, but it can be any text string, and I think it's up to 30 characters you're allowed here. So I could call it my loop, but if I did that, I'd have to change this to my loop, that to my loop, and that end A there to my loop as well, and with a bit of luck that's going to work exactly the same way as it did before when we first looked at the preprocessor. So you can give them a name. People tend to use A as the names of their loops, and then if they want a loop within a loop, they go B within that loop, because you can do loops within loops to expand lots of code very quickly. Now, what else can you do with do loops besides just going from 1 to 5? Well, there's some things that you can do. You can also go in steps. So this will tell it to go into a loop which starts at 1, ends at 5, but steps up in 2. In other words, it'll do 1, 3, and 5. Or let's expand it a bit further and make it 11, so it does 1, 3, 5, 11. So let's look at that and see what it does. In the listing file, you can see now the variables I got are Q1 underscore 1, 3, 5, 7, 9, and 11. And the column numbers step up accordingly. Now that's probably not what I want. So we possibly want some different tools when things step up in different steps. Well, let's just look again at a basic loop, 1 to 11 here. So this is going to produce 11 variables. So the first time it comes through here, my loop takes a value of 1. So what it's going to substitute when it sees my loop in a square bracket is the value 1. And the next time 2, the next time 3. You can do arithmetic in here. So what I'm telling it to do here is the value of my loop is 1. And if I add 5 to that, I'll get a total of 6. Whereas the next time through, when my loop is 2, this will take a value of 7, because 2 plus 5 is 7, right up to the 11th one when we add 11 and 5 together, and we'll get 16. So let's just check that does what we think it'll do. And sure enough, I've now got 11 variables that run from 6 to 16, called Q1 underscore 1 through to Q1 underscore 11. So that's all good so far. That's done do loops, we've done steps. The other thing that you can do here is that you might find that life isn't quite as simple as this. Say that these columns here step up in steps of 2, whereas this has got to go from 1 to 11 sequentially. You could have those stepping up in steps of 2 as well, but it's probably not tidy in terms of the naming of your variables. It might be quite confusing. So let's say the column numbers have got to step up in steps of 2, but the variable names don't. Now we have a way of doing that, and we can use a set command to deal with that. So I can say that the column number, let's call it col, I can give it any name again that I want to, is 6. And what I can put in here then is, rather than my loop plus 5, I can put in the word col. Now if we leave it like that, what's going to happen is that everything will be in column 6, every single one. But we want this one to be 8, then 10, then 12, then 14, and so on. So let's look at how we can do that. In here, I can say set col is col plus 2. So without coming out the loop, it's very easy to put that afterwards and think it's doing what you want, but it won't do what you want. It's got to be inside the loop, and then magically we get everything as we want. We get the variables called Q1 underscore 1 to 11, and we get the columns going 6, 8, 10, 26, up to 26. So that's a way of having sort of different things stepping in different amounts, and you could have another set command that stepped up in steps of 4, for example, if that was what you wanted. That's less likely, I suspect. Now another thing you might want to do, you might have a loop within a loop. So here we've got a loop of 11, and let's say that's for 11 brands, and let's say for those 11 brands we're asking the same 3 rating scales. So we might decide that we want star do b equals 1 to 3 inside this loop. The columns might step up in steps of 2 still, so we want that inside the loop. And we want to make a new variable name, so we might call this in here rating B. Okay, so let's now see what we get. Now we've got a hell of a lot of variables here. Now we've gone Q1 underscore 1 rating 1 for brand 1, that's in 6. Q1 underscore 1 rating 2 is in 8, all the way down to Q1 underscore 11 rating 3, which is in 70. So we've managed to now pick up 33 variables in just a couple of lines of code. And the thing that's nice about this is that I can be sure, pretty sure anyway, if the first one is right and the last one is right, I've got everything as I want it. Very, very quick to check, and it makes table checking quicker as well, actually, because you can start to trust tables and not have to look through every single table when you're checking them, because you know they're in a loop, that things are going to work as you expect. So we've constructed a loop there using a set command and using do loops. The other type of statement that you've got that's quite like a do loop is a for loop. So we can also have for loops. So we can say for A is 10, 12, 17, 23 and 29. Now for loops are where you want to specify exactly what values you want to place into your loop. So rather than any pattern like there was here, we've got a pattern here that goes from 1 up to 11 and then another loop here that goes 1 to 3. I actually want to pick the values that A takes as it goes through this loop. So what I might do in conjunction with this is to say set Z equals 1, so that in here I can say that Q2 underscore Z equals column A 1 to 5. So I've now got set Z equals Z plus 1. So what I'm going to do now is I'm going to get variables called Q2 underscore 1 through to Q2 underscore 5, because there's 5 things in here. And the columns that they're going to use are going to be the values of A, which are 10, 12, 17, 23 and 29. Let's look at this. And sure enough, if we go down to Q2, I've got Q2 underscore 1 comes from column 10, Q2 underscore 2 from 12, and so on. Of course, I should say that all of these tools are available anywhere in MRDCL. I'm doing this in the data stage for illustrative purposes, but it could just as easily be tables, the manip stage. You can use the preprocessor in any of those stages, or indeed the print stage as well. So that's a for loop. We've covered do loops, and we've looked at set commands. Now the other tool that you get, and is quite useful, is a data statement. Sometimes you want to store things in a list. So let's say we want to pull in a title for each of these variables here, relating to each of the brands. So I might put that in a data statement. Data statements can be numbers or they can be words, so you can, or a mixture. So I can put data statement brand equals brand A, brand B, and brand C. So they're the 3 brands that we're testing in this loop here. So I might want to put a title in that says Q1 rating brand.B. So that's going to pull in the brand we're talking about for that particular rating statement. And of course there's 11 different statements that we're actually rating here. So I'm going to say statement equals, and I'm going to call it statement 1, and this would normally be text. I wouldn't normally copy and paste. If it really was statement 1 to 11, I could do that within a loop, but we're assuming that normally that would have some text that would vary. And there's my 11 statement. So in here now I could slot in statement.A, and now I've got my title. Oh, I should have made that my loop, not A. That was my mistake there. So let's make it statement.myloop, and with a bit of luck that's all going to compile now, and now I get my titles in. So Q1 rating, statement 1 brand A, statement 1 brand B, and I'm pulling all those texts in from data statements. And so if I change this second one here to service you'll see that the second one is replaced with the word service. It's not just pulling in the statement number, it's pulling in the word service there. And let's just change one more. Price. So the first two do have proper titles, and we've got price and service now being correctly labelled for each of our variables. Now you'll notice that each of these things here are delimited with a comma, so that's absolutely fine. What you can do now is, if you want to, you can put them on the same line or anything you like. It's like the rest of MRDCL, you can have these on the same line. The comma is the delimiter, so that's absolutely fine as it is. I prefer to lay mine out in separate lines. Another thing that you can do is you can ask MRDCL to count how many statements in there. So we could say set count statements equals statement.hash. Now that special notation there, statement.hash, says return in here the value of the number of statements that we've got into count statements, which means that rather than putting 11 in here, I can put in count statements and it will do the same thing. So loops don't have to be just driven by numbers, they can be driven by a count or a value that you've set somewhere else. So let's just do that, run it again, and we will get exactly the same code out going down to Q1 underscore 11, because it's counting the number of items in that data statement quite correctly and applying that to my loop here. The other thing you can do with that as well is you can put settings here. So we could say that pp brands equals less than greater than, and in here I could make my loop the value that's set. So what this is going to do is promptly, when I run for the number of brands, that means promptly for a pp value, preprocessor value for brands, and apply it here. So if I compile, I type in 3, and it's done everything for me, just as I would hope. So really clever tools in here for counting, for prompting the user for a value, and so on. So let's just take that out, because I don't want to keep that there. I want it to automatically do what I'm doing, and I'm going to turn that back to 3 so that it just runs with a fixed value of 3. So we're making some progress now. So we've done do loops, we've done for loops, we've done data statements. One thing that can be a problem is if you want a comma within the data statement itself. Now, the default delimiter for a data statement is a comma. If you want to change that, you can put it in brackets before the equal sign, and now the delimiter is a hash symbol. So I can now go down these, and now hash is the delimiter. You don't need a comma after the last one, and hash is now the delimiter. And what it means is I could sort of put a list of things here: price, performance, and offers, something like that. And now that comma will not get read as the delimiter. Price, performance, and offers will get treated as one statement, because hash is now my delimiter. And there you go, you can see that we've got that in there coming out quite correctly. If I didn't do that, it would get confused and start to treat, if I didn't put that code in here, it would start to treat that and performance and offers as a separate item in the data statement, because they're allowed on more than one on the same line. Alright, so we're doing quite well here. Let's look at the next feature that we want. Now, another feature that you've got is a data CSV statement. So let's look at that. Now, I've got a data CSV already sitting here. So here's a little CSV file that I've already made. And what this has got in it is a variable name, a column, and a title. Now I'm just going to quickly change that to Q3 underscore 1 so it doesn't clash with what I've done already. There we go. So here I'm going to pick up my variable name from this column here, the column number from here, and the text here. Alright, let's look how we do that and what we can do. So the first thing that I can do is I can say that start data, and I'm going to give it a number this time, 200 CSV. It's called ratings.csv, so I can put ratings.csv in here. The .csv is actually optional. If it has a path, you can put a path in here, so you could say z:\/ if it was in a different drive or folder. So that's fine. I can use the set command to say ratings CSV ratings count is 200.hash. So using the same notation as before, I can count the number of cells in this spreadsheet. Well, you'll note that it's got 8 rows and 3 columns, so it will return a value of 24. If you want to check these sorts of things out, you could actually put this information out. The number of cells in the CSV file is, and in here you can put ratings count, and that will actually come out as a comment because it's got exclamation mark on the front. Let's just see that in action. It doesn't like the fact I've got it open, so let's just shut it quickly. CSV files have to be shut while they're in use. Okay, let's retry that. Well, it's actually errored, so let's retry it again. And it looks as though it's worked now. And down the bottom here you can see it says the number of cells in the CSV file is 24, which is what we would expect. We come back and edit this now, and what I can do now is I can set up a loop that runs from 4 to ratings count in steps of 3. Now the reason I'm doing that is because the way it works with a CSV file, and let's just reopen it before we go any further. And it's just opening now. The way it works is it says, well, this is cell 1, this is the second, or item 1, this is 2, this is 3, then it wraps around to the next row. So that would be 4, 5, 6, down to 24. So I actually want to start my loop at 4 because that's the 4th item in the list in the way it counts it. Which means that I can do something like this. I can say that ds $200.a equals $200.a plus 1. So what it's going to do now, it's going to pull in that value there, 23. And let's say it's codes 1 to 5. And the title is 200.a plus 2 because that's 2 further on in the loop. Let's see if that's working. Let's close this. As I said, it doesn't like the CSV file being open. And sure enough, we have a look at it now. We go down to the bottom, and there we go. We've got Q3_1s in 23, Q3 2044, but we've got those texts coming through. What's really nice about this now is if I add something to this CSV file, it's just opening, let's add one more in. Let's say that's in field 99, rating of information pack. So now we've actually got 27 cells in this worksheet. There's the first, second, third, there's the fourth, there's the 27th. I don't actually have to change my script at all. Nothing changes here. I'm just going to save this and overwrite it. And now I go back to my script and I can just run this without changing a line of code. And I've just got an error in there. Let's just have a look what happened. It's errored because I've got location 99 and I've rather carelessly not set the record length here. So let's put in a card characters 200 and it should now work, and indeed it does. And so there's my extra statement, Q3_99, 1 to 5, rating of information pack, and everything has worked absolutely fine for me again. Alright, so that's a data CSV file. Another thing that I can do is I can have skips in my script. There's various ways of doing this. If I just have a piece of code that I don't want anymore, say I don't want that code anymore, I could just say skip 500 and put the statement star 500 into that, and that will allow me to just skip that piece of code entirely. So I can now say compile, and you'll now find at the bottom Q3's gone away because I put a skip around that code. So if you've got a piece of code that you temporarily don't want, you can put a skip around it, and that will miss it out completely. Another use of skip is where you want to perhaps do different runs. So I've seen this sort of code. I've seen things like, well, if it's the UK, the region might be in column 50, 1 to 3, X equals code north, central, south. Whereas if it's another country, we might have, in the same data location, completely different fields, which are north, south, east, and west. Now that's going to not compile. That's not going to compile because one variable's got 3 codes and one's got 4. So if I try and compile that, you'll see I'll get an error, and it says I've got a faulty redefinition. So what I want to do is that depending on which run I'm carrying out, I can ask it to do different things. So I could say skip 99 on country not equal to 1. And for this piece of code, I could say skip 99 on country not equal to 2 for this piece of code. Now all I've got to do is put in a statement at the top here that says pp country is less than greater than. Now when I enter a 1, if I look at my listing file, it's going to pick up 3 region codes. However, if I go for country 2, it's going to pick up 4 region codes. So I could use this same script to manage 2 versions of my questionnaire for 2 countries, for 2 different types of users, whatever it might be, and have it all controlled by the by the PP setting at the top here, which is then skipping around the code that I don't want for that particular run that I'm executing. There's also another way of doing that using an ask command. An ask command puts a menu up at the screen so that you can ask the prompt, and so we can do something very similar there. So we can say, we can take this out, and up the top here we can say star data 500 equals UK and Germany. So let's say there are 2 countries. Then we can say star ask country equals 500. Run it, and we get a little menu coming up. Now if I click UK, that's going to return a value of 1 to the run, and sure enough, once again we've got 3 regions here, whereas if I compile again and I pick Germany, you'll see that it's picked 4 regions, north, south, east and west, and I've got something different happening. And of course that list could be as long as you wanted. So that's a skip command. Skip commands also come in useful when you want to output some labels. So let's say that we wanted to put in some labels here which were 1 to 5. So let's say we want to put the labels in here as x equals quote, and we want a loop of 5 things. Now this won't quite work as I want it to. It's going to give me 5 labels called score 1 to score 5, but it's going to put out 1 more semicolon than I want. An MRDC will think there's a blank label at the end. So let's just see what happens when I do that. Let's pick the UK. Okay, and you can see I've got a whole load of errors here because it thinks after that semicolon there's a blank label in here and it's got an extra label. So one way round that would be to skip over that semicolon when it's a value of 5. So I could put in a skip command here that said *skip 33, that can be any number I like, C equal to 5, and it would skip over that semicolon when C takes the last time round that loop, and it should now compile, doesn't matter which country, and sure enough now you can see that semicolon's been omitted and I've got a quote comma there. So skip number or statement number when a value is equal to, not equal to, greater than, less than, is all perfectly good syntax in here. There is another way of doing it that's even quicker though. So rather than having this in here, what I could say is StartSLE, which is a shorthand way of saying skip to the end of the loop on the last time round. So when it gets to 5, just skip to the end of the loop, and so that would skip over my semicolon as well. So that's a short way of saying exactly the same thing, and hopefully now we're going to get out what we want as well in a shorthand way. But the other method did sort of go through the way that you can skip on a particular value, or if a value is greater than a certain value, and so on. So that sort of completes this introduction to the preprocessor. It's covered most of the tools that you'll be using when you're using the preprocessor and most of the things that you need to learn. It's a little bit more difficult than normal scripting, but really there aren't very many tools and it really can save you a long time. In the next video, you'll be able to find out how you can correct errors and spot errors in preprocessor loops that you've written. So that's at the end of this video for now. Thank you.